All these new microservice-based architecture became a standard for designing a modular, scalable software architecture. You will face, at certain moment of growth, challenges of splitting monolithic applications into microservices. So we need to split and properly define responsibilities for each microservice and learn how to let them communicate whilst keeping a high level of maintainability and evolvability. And now, about this. As one's code bases grow, it is inevitable that their complexity will increase. As this happens, it tends to get more difficult to keep code organized and structured as originally intended. This is known as software entropy. Over numerous iterations, maintaining good separation of concerns and properly decoupling classes and modules becomes more challenging if no strict architectural guidelines are enforced. Naming things, for example, has always been one of the most difficult challenges software developers face. We should be clear enough for other developers to understand our intentions in the code, while using appropriate naming choices that can facilitate a conversation with business stakeholders. So domain-driven design, DDD, comes along and attempts to solve these challenges by reconciling the technical and non-technical forces that collide in a software project and proposing a set of practices and patterns that facilitate building a successful system. On the other hand, strategic design is a set of principles and patterns for maintaining model integrity, distilling the business domain model and working with other multiple models. Strategic design is very useful to divide a large and complex business problem into multiple chunks with clear boundaries and specific responsibilities and build a high-level software design topology. And technical design is a set of design patterns and building blocks that you can use to abstract low and mid-level components of the code. Technical patterns are very hands-on, addressing programming code and deal with classes and modules. The purpose of technical design is to refine the result of strategic patterns applied to a stage where it can be converted into a working code. Therefore, domain-driven design is an evolving process consisting of iterative cycles of applying strategic and technical design. You start with strategic design, followed by technical design. So, bottom line, the part of the code that is written to specifically solve domain problems is a fraction of the whole codebase. If this portion is mixed with code that solves other concerns, it will be difficult to understand and improve. Clearly separating domain logic from all other functionality will reduce the leakage and will avoid confusion in a large and complex system. So domain-driven design proposes then a layered architecture as a way to separate concerns and avoid responsibility and confusion by splitting the codebase in 4 main layers: the user interface, the application, the domain, and infrastructure. All in all, domain-driven design is a holistic approach for solving business problems through rich collaboration with domain experts and strict design patterns. It is not an universal solution for all software problems, but it can provide significant benefits when properly applied. So, what do you think? Let me know in the comments below. See you on the next episode.